so excited you are watching this video. I hope it helps you a lot. Alright, so today let's go ahead and get started. We're going to still be talking about that common denominator, okay? So let's take a look at an example here. We've got 3 over x minus 2/4, and that equals 8 over 4x. Alright? So the first thing we need to do here is take a look and find out what is the common denominator. What can I multiply all of these by to start canceling out? Well, if I'm looking, I see that that's going to be 4x. All right, so I'm going to multiply all of this by 4x. All right, so if I use my distributive property here, I'm going to go ahead and multiply all of these by 4x. When I do that on this first one, the x's are going to cancel out, leaving me with just 4 times 3. 4 times 3 is 12. Yes, excellent. All right, on this next one, the 4's are going to cancel out, leaving me with 2x. All right, and then on this one, the 4x's are going to cancel out, leaving me with just 8. Perfect. Now we have a much easier problem to work with, right? So now, still trying to isolate that x, so what I need to do now is subtract 12 from both sides. All right, so now that's going to leave me with negative 2x equals negative 4. All right, perfect. So now all I have to do is divide by negative 2, and I'll find out that x equals 2. Woohoo! All right, awesome job. So what I would love for you to do right now is to work on one of these by yourself. So why don't you try x over x minus 2 plus 1/5 equals 2 over x minus 2. All right, perfect. I know you guys can do this. All right, so you go ahead and do the best you can. We'll go over this on the video tomorrow. Oh man, I bet I got you guys good. Y'all are just laughing. All right. So let's go ahead and look at the problems, the real problems that you worked on yesterday. All right, so in your book on page 189, you worked on 3D. All right, so that one was 19 and 3/15 minus 8 and 4/5. Okay, so first thing that you need to look at is we have unlike denominators. So we need to find the least common denominator here, all right? And so the least common denominator, remember, to find that, you would do the multiples of each denominator. So if we wanted to write those out, if we did the multiples of 5, 10, 15, 20, all right? And then you got the multiples of 15, 30. Oh, well, I already have one in common there. That's going to be my least common denominator. My least common multiple equals my least common denominator, okay? So these are the common multiples. They're the least common multiples, which is also the least common denominator. All right, does that make sense? Hopefully. All right, so I'm going to change these into equivalent fractions with the denominator of 15. All right, so I'm just going to go ahead and first just bring over the whole number. All right, and then 15 is the denominator. Well, this is already 15, so I'm just going to bring the 3 over 2. So you ask yourself, how many times, or what do I multiply 5 times to get 15? All right, so that's 3. I have to do the same thing to the top. 4 times 3 would be 12. All right. I still can't subtract though, can I? Because I've got a smaller number on the top. Just like in regular subtraction, you can't do that, okay? So I need to borrow, just like in regular subtraction. I'm going to borrow 1 from this 19. I'm going to make it into an 18. All right? I'm going to take that 1 that I borrowed and make it into a fraction. What fraction? Whatever that denominator right there is, because I'm going to be adding to it, okay? I'm going to be adding the fractions together. This is a 15. I need to make a fraction that equals 1 with the denominator 15. That's going to be 15 over 15, okay? 15 over 15. I'm now going to add these two together, all right? That's going to give me 18, and then 15 is going to still be my denominator, but then now I'm going to add 15 plus 3, that's 18, okay? So I'm going to have 18 over 15. The bottom, just going to bring over, not doing anything to that. Now I can subtract because I have like denominators and I have a larger number on the top. Okay, so if I subtract at this point, 18 minus 8 gives me 10. Leave the denominator alone. Now 18 minus 12 would be 6. All right, that's a 1 right there, by the way. I can reduce this, okay? I can reduce 6 and 15. There's a number I can divide both of those by. That number is 3. So if I divided 6 by 3, I would get 2. 15 by 3, I would get 5. All right. Oops. Let's just write that there. So my answer would be 10 and 2/5. All right. 10 and 2/5. All right. So then the next problem we worked on was the story problem number 4A. All right, so if you read that problem, you should have saw the word of there, and remember what of means? It means to multiply. So it says he has used 1/6 of the pencil, and we know that the pencil was 11/12 of a foot long. So 1/6 of 11/12. All right, so I'm just multiplying straight across the numerator, straight across the denominators. That would give me 11. 12 times 6 is 72. All right, so I can't reduce that, so you should have 11 over 72, and that would be of a foot used. All right. All right, so then if we took a look at 4B, all right. So Madeline bought 36 apples for 47 cents each. The story problem wants to know how much did the apples cost in all? Well, to find that out, I would need to multiply. All right, I'm going to multiply 36 apples times the 47 cents. All right, so that's going to be all I do there. I just multiply that out. So that's going to give me 42. 21 plus 4 would be 25. All right, put my 0 down there. Now I go 6 times 4 is 24. All right, 4 times 3 is 12. Plus 2, 14. Okay, now I just add 2, 9, 6, and 1. Okay, and I'm going to put my decimal there because I've got two spots there. All right, so $16.92. All right, so she paid $16.92. That's how much they cost in all. All right, so then you looked at 5A and 5B. All right, so 5A, that was addition, so you should have gotten the answer of 265. And for B, the answer would have been 462. That one was addition, B was subtraction. All right, just remember to take your time on those. I know you know how to do those. Just sometimes we get too fast in trying to solve the problems and we make small little mistakes, but it throws the whole problem off when we don't take our time. All right, so that is what you worked on yesterday. So great job on all of your hard work on that. I really appreciate all you're doing. All right, so now, today we're taking a look on page 190. So let's start off with looking at F on page 190. All right, so this is a fraction problem, so it's 5/8, 1/4, and 2/8. I am adding these together, all right? I can't just start adding here, right? These 2 are the same denominators, but this one's not. I have to have all the fractions have the exact same denominator. So I would need to go make equivalent fractions. All right, remember I found the multiples, the common multiples, the least common multiple, and that's the same thing as the least common denominator. All right, so if I did that, I would know that 8 would be my least common multiple and my least common denominator, okay? So I'm going to make all of these into equivalent fractions with the denominator of 8. Well, this is already 8, so I'm going to bring it over. This is already 8, so I'm going to bring it over. So the only one I need to change is the 1/4. Okay, so you ask yourself, what do I multiply 4 by to get 8? 2. Okay, I have to do the same thing to the top. So I'd multiply that by 2 to get 2. Following me? I hope so. All right, now I can go ahead and add because I have all like denominators and I'm just adding. So here we go. So 8 is still the denominator. So then I would add all of these together to get 9. Is that my final answer? Can't be. Why? This is an improper fraction, okay? Improper. I can't leave that as the answer. I hope you remember how we make that into a mixed number. I know you do. So we have to divide. Okay, we're dividing. The smaller number always goes on the outside, remember? Okay, so we're going to put, how many times will 8 go into 9? Just once, okay? 1 times 8 is 8. I subtract, I get 1. Numerator, denominator, whole number. All right, whole number would be 1. Numerator, 1. Denominator, 8. All right, so my final answer would be 1 1/8. All right, there were a lot of steps in that problem. We just need to take it one step at a time. Don't feel overwhelmed by it. Just one step at a time and get through it, okay? All right, now let's take a look at G. All right, G says 16 3/4 and minus 12 1/2. I can't just start subtracting here either, right? Because I don't have like denominators. I need to make equivalent fractions again. If I were to write out all of the multiples, I can do this one in my head. Maybe you can. If you can't, that's fine. Just go ahead and write it out. But I would know that my least common denominator here is going to be a 4. Okay? So this one's already 4. Just going to bring that over. What do I multiply 2 by to get 4? 2. Going to do the same thing here. It's going to give me a 2. All right. Don't forget about the whole numbers here. I usually write them, but I didn't that time, so don't forget them. All right, so if I subtracted 16 and 12, that would leave me with 4. Gonna leave the denominators alone. 3 minus 2 would be 1, okay? That one wasn't too bad, right? All right, so 4 1/4 would be the final answer for G. Right, so let's take a look at H. 89 1/7 plus, adding this time, plus 62 and Miss Durham cannot see 3/14. Okay. All right, so I'm adding, but when I'm adding, I still have to have the like denominators. I don't here, so I'm going to have to make equivalent fractions. All right, so this time I'm going to write the whole numbers here. All right. All right, equivalent fractions. Well, I can see right here that it is going to be 14. 14 is my least common multiple and my least common denominator. Okay, this one's already 14, so I'm going to bring that over to 3. What do I multiply 7 by to get 14? 2. All right, so multiply the top by 2. I get 2. Now, yes, that is lower, but I'm just adding, so it doesn't matter. So 2 and 3, I'm going to add those together. I'm going to leave the denominator alone, and then I'm going to add 89 and 62. All right, 89 and 62 is going to be 151. And then I just add 3 plus 2, adding, not multiplying, adding. I'm going to get a 5. All right, so 151 and 5/14. That's a big one. All right, so, but I didn't have to do anything else except for make sure that the denominators are alike and make equivalent fractions, okay? All right, so then let's take a look at I. 1 minus 1/2, okay? I have a whole number and I have a fraction. I need to rewrite this number 1 into a fraction, all right? What fraction? I'm going to look at this denominator. It's a 2. I need to have like denominators, so I need this fraction to be a 2 in the denominator. If it's a 1, the numerator has to be the same thing, so it would be, I'm just changing the 1 into 2/2, okay? Now, I can subtract. Leave the denominator alone. 2 minus 1 is 1. All right, that one wasn't so bad. All right, now let's take a look at J. 5/11, 4/11, and 9/11. And I'm just adding. I already have like denominators. Perfect. So, just going to bring that down. Now I'm just going to add 5 plus 4 plus 9 would give me 18. Can't be my final answer though, right? That's an improper fraction. I've got a larger number on top for the numerator, okay? That won't work. I'm going to need to divide. Smaller number goes on the outside, larger number on the inside. How many times will 11 go into 18? Just 1. All right, 1 times 11 is 11. Subtract, all right? So I'm going to get a 7 here. And my numerator, denominator, whole number, okay? So when I write this as a mixed fraction, I'm going to write my whole number as 1, my numerator as 7, my denominator as 11. And that is it. I cannot reduce it, so my final answer will be 1 7/11. All right. That is it for today. I know that was a lot of work. Hopefully you went through that with me. If not, you can watch this video, go back and do it. Just watch it. You can watch it as many times as you need to let that sink in and hopefully start to make sense to you, because I know it's been such a long time since we've done those. It's hard to remember. So that's why I wanted to go through those with you today. All right. So, but if you have any other questions about it, get on that video conference call with me, call me, send me an email. I'm here for you, okay? So whatever you need help with, I'm here for you. All right? I hope everyone has a fantastic April Fool's Day. I hope you get some pranking in there. Not to me, of course. All right. So I'll have another video for you tomorrow. Bye.